Okay, this section is all about proving trig identities. So let me first of all just show you how to simplify an expression. So we really need to have all of our identities, everything that we know so far about the trig functions can come in handy. Okay, so if I'm going to simplify this, a lot of times it helps just to write it in terms of sine and cosine. So cotangent is cosine over sine. So cotangent squared would be cosine squared over sine squared. And then cosecant is 1 over sine. Okay, so cosecant squared would be 1 over sine squared x. Okay, now there's a common denominator, so let's go ahead and subtract our fractions. So we've got in the numerator cosine squared x minus 1. Now we do have a Pythagorean identity that says that sine squared x plus cosine squared x is equal to 1. So if I subtracted cosine x from both sides, I would get 1 minus cosine squared x is equal to sine x. Okay, so keeping that in mind, what I'm going to do is I'm actually going to commute my cosine squared x out to the back. Cosine squared x. So it would be negative 1 plus cosine squared x. Okay, that's just by commutative property. And then I'm going to factor out a negative 1 squared x. Oops, sorry, that's kind of in our way. All over sine squared x. And then I'm going to use my trig identity here, that Pythagorean identity, and I'm going to replace 1 minus cosine squared x. I'm going to replace that with sine squared x. And then I can just simplify this fraction and I'm left with a final answer of negative 1. Okay, so that process of just showing all of our work, showing our steps, working down the page vertically, that's what's going to be required as we go into our next step. And every single one of our steps has a really clear reason of why that was allowable. All right, so let's prove some identities. So what we're going to do is we're going to choose a side. We're going to start on one side. We're going to work vertically down. It's not like solving an equation. You can't move things from side to side. Instead, on your chosen side, you're just going to use whatever algebra, definitions, reciprocal properties, the Pythagorean identities, whatever you can think of to simplify your chosen side. Okay, so choose a side and simplify it. And then our goal is to eventually end up with a simplified expression that matches the other side. That's our goal. Okay, so I'm going to choose a side. A lot of times it's helpful to choose the more complicated side. So I'm going to choose my side, and eventually after doing all my work, what I want is for this to be equal to sine of x. So I'm going to start with 1 minus cosine squared x all times cosecant of x. And I'm going to simplify, 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 simplify. And I hope that eventually it's going to work out to be equivalent to sine of x. And then I will have proven my identity. Okay, so let's see. 1 minus cosine squared. That is a Pythagorean identity. So I can replace that with sine squared of x. All right, and now I'm going to use the definition of cosecant. That is 1 over sine of x. And now I'm going to multiply my fractions. So I'm going to give myself, just multiply straight across, and I would get sine squared x over sine x. And then I'm going to go ahead and simplify this equation, or this fraction here. So then that would be sine of x. And that was my goal. Okay, so what I've just shown is that 1 minus cosine squared of x all times cosecant of x is equal to sine x. And I rest my case. In math, we say QED, which is Latin for I rest my case. What I meant to show is shown. Okay, here we go. I'm going to choose my side. This certainly looks to me hard with all those cosecants and cotangents and stuff. Okay, so I start with that. Cosecant squared x minus cotangent x minus 3 all over cotangent x plus 1. Okay, I'm just racking my brain. I have my handy sheet with that review of all my fundamental identities, and whenever I see a squared, I'm going in and thinking about the Pythagorean identities. Okay, cosecant squared, that's the same as 1 plus cotangent squared of x. Okay, so I'm going to just replace that and then continue copying the rest of this fraction. So it's minus cotangent x minus 3 all over cotangent x plus 1. So now let's see. I just can combine numbers here, a 1 and a 3. So I'm going to have cotangent squared x minus cotangent x minus 2 all over cotangent x plus 1. Now let's do a little factoring. If I had y squared minus y minus 2, and I asked you way back years ago when you were asked to just factor that, you could factor it as y minus 2, y plus 1. Okay, so dust off your factoring skills. It may have been a little while, but here's what we're going to do. This is going to be cotangent of x minus 2 times cotangent of x plus 1. Okay, so I had this was y squared, so it went to y minus 2, y plus 1. So instead of y, I have cotangent, so that's factoring out to cotangent minus 2, cotangent plus 1. Okay, and now I'm going to have my denominator is still cotangent of x plus 1. Hey, do you see what I see? Anything divided by itself is just 1, so this simplifies down to cotangent of x minus 2. Okay, let's see what we were setting out to prove. Look, we just did it. We were setting out to prove that the left-hand side is equal to cotangent x minus 2, and we have finished. What I set out to prove, I just proved. I am done. All right, in this proof, I need to show that cotangent of theta plus tangent theta is all times sine theta is equal to secant theta. And unlike an equation where you get to manipulate both sides, with a proof, you only get to work on one side of the equation. Okay, so I'm going to start by rewriting my cotangent and tangent in terms of sine and cosine. Cotangent theta is the same as cosine over sine, and tangent is sine over cosine. All right, and all of that is still being multiplied by that sine theta. And now a strategy when you have two different fractions, the sum of fractions, is to combine those by getting a common denominator. So I'm going to use, let's see, I'll just copy this down. Sine theta. Okay, so my common denominator I'm going to use is going to be cosine times sine. And whatever I do in the denominator, I need to do in the numerator as well, because I'm not changing the value of anything over here on the left-hand side. So multiplying by cosine over cosine, that's just the same as multiplying by 1. And then it allows me to get a common denominator. All right, so my second fraction, I have sine over cosine. And so that denominator needs a sine. What I do to the denominator, I need to do the numerator as well. Okay, so now that's all still multiplied by that original sign under there. Okay, so my common denominator is cosine theta times sine theta. And here cosine times cosine, that would be cosine squared. And here sine squared plus sine squared is, or sorry, sine times sine is sine squared. And that is a trig identity. Cosine squared times sine squared is equal to 1. Oh, and I don't want to forget that that's still multiplied by sine. All right, so I replaced cosine squared, sine squared with 1, and I still have that same denominator, cosine times sine. And now my sine, I'm just going to write that as sine theta over 1, because then you can see that I'm multiplying fractions, and my sines will cancel, and I have 1 over cosine, which is equal to secant, and that is what I wanted. Okay, so with a proof, again, you're only working on one side of the equation, and at the end you're showing that all that work left you with what was originally on the other side of the equation. So that's what a proof looks like. We can't manipulate both sides of the equation, so it's not like an equation, we're just working on one side.